Right, next up is chapter 3, which is mainly derivatives, and the first part of it is derivatives of polynomials and exponential functions. So there are a few things that you have to know. That the differential of c of a constant is equal to 0. Then the power function law is the differential of x to the power of n is equal to n, and x then n minus to the power of n minus 1. Okay, so an example of the power function will be the differential of cube root of x to the power of 4. So cube root of x to the power of 4 can just be written as x to the power of 4 over 3. So it's the differential of x to the power of 4 over 3. Then you bring down the n and you subtract 1 from the power, which means you'll be left with a third. Okay, and these are some of the other things that you have to know. You can apply the product rule. So if you multiply by a constant, then you can take the constant out and then differentiate the function in x. And addition, so if f of x are differentiable, f of x and g of x are differentiable, then if they're added together, you find the individual differentials and add them together. Same with subtraction. You can find the individual differentials and then subtract those differentials. Then moving on to the exponential function. So the exponential function, the derivative of the exponential function is equal to the exponential function. So if you have the derivative of exponent of x, you still get exponent of x. For example, another example, look at this one, y being equal to exponent of x plus 1 over x. Hence, you can rewrite 1 over x as x to the power of -1, and then the differential becomes exponent of x because exponent of x does not change. Then you bring this -1 down, then you subtract another 1, which makes it -2. Hence you get your differential is exponent of x minus 1 over x squared. So the product rule. So this is the product rule, the simplified version of the product rule. So you have this function and that function, so they're being multiplied, and you're supposed to find the differential of the product of the two. So you can find the differential of f and then multiply it by g plus the differential of g multiplied by f. So with the product rule, you're supposed to know it and prove it. So you're supposed to be able to do the whole proof of the differential equation. It's there in the notes provided by 123tutors. Then moving on to quotient rule. So you now have your functions f and g dividing each other, and then you are required to find the differential of that. So it's the differential of the numerator times the denominator minus the numerator times the differential of the denominator over the denominator squared. And you just need to know this one, you don't have to prove it. So an example would be this one for the product rule. So it's y is equals to x to the power of 3 over 2 times x squared minus 1, and then you work it out. Then for the quotient rule, use y is equals to exponent of negative x. So exponent of negative x is 1 over exponent of x. So by applying the quotient rule, you get 0 minus exponent of x over exponent of x squared. Hence your differential becomes negative exponent of negative x. Okay, so there might be some questions whereby you're required to determine the equation of the tangent line. So the tangent line basically follows the basic equation y is equals to mx plus c, the equation of a straight line. So the gradient is the same as the derivative. So you'll be given a point, let's say for example 0.11, then you can find the derivative, and then once you find the derivative it would most likely be in terms of x. Then you can substitute your x value in order to get your derivative, which is your gradient m. Then you can just do your y minus y1 being equal to m x minus x1. Then you get your equation. So the tangent line equation is gradient equal to the derivative of that equation. Okay, moving on to trig functions. So it's the differentiation of derivatives of trig functions. So the first three are of our basic three functions is the sine, the cos, and the tan. So the derivative of sine will give you cos, and the derivative of cos will give you negative sine. And these two you're supposed to prove them. Yeah. So you should prove the differential of cos of sine and the differential of cos using limits, and the differential of tan, cot, cosec, and sec. Those ones now you can now just apply your general knowledge that, for example, in this case tan is equals to sine x over cos x. Then by that you just go from differentiating these, you can use your quotient rule, then you end up with sec squared x. So you should be able to prove the differential of sine, the differential of cos, and also you must prove that the limit as theta goes to 0 of cos theta minus 1 over theta is equal to 0. So in the proofs that are provided by 123tutors, you actually find these proofs, and then you can just practice on them and get to see if you understand them. And then moving on to the chain rule, if g is differentiable at x and f is differentiable at g of x, then caps f, which is f of g, or f of x, caps f of x, which is f of g of x, is differentiable at x, and this is given by f prime of x being equal to f prime of g of x times g prime of x, or y being equal to f of u and u be equal to g of x. Then your y is just equal to your f of g of x, and you can apply this formula, dy dx being equal to dy du times du dx. These two du's will cancel, then you'll be left out with dy dx. So for example, you're given y being equal to the square root of 4 minus 3t. You can say your u is equal to 3t, hence your y becomes u to the power of half. Then you can find du dt and your dy du. You do your chain rule, then you get that, and then now you can go and replace your u with your 4 minus 3t. Then you get negative 3 over 2 times 1 over square root of 4 minus 3t. So these are other forms of the chain rule that you might want to apply. So for the first one is d dx of any function f of x to the power of n. So it's more of like an adaptation of the power rule. Yeah, the power rule. So you're going to multiply by n, bring down the n in f of x, and then you reduce your power by 1. Then this time around you're going to multiply by the differential of the function that's inside the bracket. So for example, if you have 6x squared plus 1 to the power of 10, and you're going to bring down the 10, then you remove 1 over there, then this one right as it is, then you multiply by the differential of this, what's in the bracket, which is 12x, then you get your answer is that. And then the other one is d dx exponent of f of x, which will be given by exponent of f of x times the differential of your f of x. For example, d dx of exponent of tan x will be exponent of tan x times the d dx of tan x, which is sec squared x. Okay, so the same applies to trig functions. So d dx of cos of f of x will be negative sine f of x times the differential of f of x. It will be the same for sine of f of x as well. You would get cos of f of x times the differential of f of x. Then d dx of a to the power of x is equals to a to the power of x ln a. And then d dx of a to the power of f of x will be a to the power of f of x times ln a times the differential of f of x. Then this takes us to implicit differentiation. So in some instances we can't really get y as the subject of the formula. So what we will do is to differentiate everything as it is, and then where we differentiate our y, make sure that we do our chain rule and end up with a dy dx in there, and we just have to make the dy dx subject of the formula. So an example is this one, x squared plus y squared being equal to 9, and then this is just the same as x squared plus f of x squared being equal to 9. So differentiating your x squared, you get your 2x. Differentiating f of x to the power of 2 will be, you have to bring 2 down and then you subtract 1, which is 2 f of x to the power of 1 times the differential of f of x, which is f prime, and then which is equal to 0 because the differential of 9 is 0. Then you get 2x plus 2y times y prime being equal to 0, which is 2x plus 2y dy dx being equal to 0. Hence dy dx is equal to negative 2x over 2y, just equal to negative x over y. Okay, now so for inverse trig functions like your arctan, your arcsine, you're going to use these. So you're supposed to be able to prove this and also apply it. So if you check on the proofs that are provided by 123tutors, you actually find out that these proofs are also there. So you just have to master them so that when they are asked in the exam, because it's almost 100% certain that there will be at least one proof in your exam. Okay, so everywhere where I wrote proof, you have to know that proof. At least get into the exam with the know-how of how to prove that theorem or that formula. So moving on to log functions. So our definition of a log function was y being equal to log base a of x. So your x becomes a to the power of y. Then now we can do your implicit differentiation. Get ay dot ln a times dy dx being equal to 1. And if you continue working on it, you'll get to see that the differential d dx of log a of f of x is just equal to f prime x. So the differential of f of x over f of x times ln a. So you have to be able to prove that one as well. So look it up in the 123tutors notes or summary of the proofs and master it. And then the derivative of ln of f of x, just f prime of, so the derivative of f of x over f of x. Okay, and then, so this is just a general summary of some of the proofs that we've already talked about. But then you come face to face with a function like this one, the derivative of f of x to the power of g of x. So here you have to introduce the ln function. So we're going to first of all say that this function is equal to y, and then you use ln on both sides, then you get this. In this instance, this example, you get ln y being equal to 1 plus ln x times ln x. Hence you have a product over here, over this side you have a product, and you can do your implicit differentiation throughout. Then you eventually get a value of the differential of y prime being equal to y factor of 2x ln x, 2 over x ln x plus 1 over x. Lastly, we'll talk about hyperbolic functions. So for hyperbolic functions, you have to know the general definition of sin x, cos x, and tan x. So for sin x, it will be exponent of x minus exponent of negative x over 2, and you have to know how to plot it. And for cos x, so exponent of x plus exponent of negative x over 2. Also have to know how to plot it. And then your tan x, tan hyperbolic x, it's going to be your sin x over your cos x. And then the 2's cancel out, which means you will only be left with your exponent of x minus exponent of negative x over exponent of x plus exponent of negative x. And then you also have to know we also have to prove the derivatives. So for sin x, you get your cos x. For your cos x, you get your sin x. And then for tan hyperbolic, you get sec hyperbolic x, sec hyperbolic squared x. So you have to be able to prove for these derivatives. And if you do that, you'll be home and dry. So now to look at some past exam questions from theme 3. So the first question, which is most common, to be determine the following derivatives, and do not simplify your answer. So I have a list of derivatives over here that I found in previous exam papers. So for the first one, it says f of x being equal to arctan of 1 over x. So if you've looked at the table, if you've memorized the table with the derivatives, you quickly discover that this is just equal to negative 1 over your x squared over 1 plus 1 over x squared as your derivative. So this is based on the fact that if you have f of x being equal to arctan of x, then the derivative of f of x will be equal to 1 over 1 plus x squared. So now here you have to put the derivative of your function inside your bracket over here. Okay, so moving on to the next one, it says f of t being equal to cos of cos t. Hence your f of f, the derivative, should be equal to negative sine of cos t times the derivative of what's inside here is times sine t, like that. Then you get your full marks. And then the next one, f of x. So f of x being equal to ln of 1 over the cube root of x plus root x, like that. So this is just similar to from laws of logarithms, ln 1 minus, then it's going to be 1 over 3 because you're going to bring this cube root down. Then you'll be left with ln of x plus root x, that. Hence now you can easily get your derivative. This one will be 0 since it's a constant, so your f of x becomes this, and your f prime of x just becomes negative 1 over 3 of 1 plus 1 over 2 root x over x plus your root x. Alright, now moving on to the fourth one, says f of x being equal to 1 plus x to the power of 1 plus x. So with this one, it will be best, since we have a power here, it will be best to use the ln function. So we're going to say y is equal to, so your y is equal to the function 1 plus x, power of 1 over x. Then your ln y will be equal to your 1 over x ln of 1 plus x. And then now you can do implicit differentiation, and this one becomes y prime over y being equal to negative 1 over x squared. So this is a product, ln of 1 plus x plus 1 over x, 1 over 1 plus x. Hence you can only be left with f prime of x, which is just y prime, is equal to your y. So your y, this is the value of your y, hence you can just put it there as it is. So that's 1 plus x to the power of 1 over x, and then negative 1 over x squared ln of 1 plus x, k plus 1 over x vector of 1 plus x, like that. Okay, moving on to the fifth question, says the derivative of sine x plus 2y being equal to y. So this one you're going to have to use implicit differentiation. So over here you're going to get, okay, so for this one you're going to get cos x plus 2y, and then the derivative of what's inside, so that will be y plus 2y prime, the derivative of y, being equal to exponent of y times y derivative. Okay, so now you can bring everything to one side, then you factor out your y prime. Hence you end up with y prime exponent of y minus 2 cos of x plus 2y being equal to cos x plus 2y. Therefore, your y prime, which is your derivative, will be your cos x plus 2y over exponent of y minus 2 cos of x plus 2y. Here's the final answer. Okay, moving on to the sixth question, which is f of x being equal to 10x over 1 minus x squared. So with this question, you can see that we have a fraction, tan x over 1 minus x squared. So the easiest thing will be to use the quotient rule. So your f prime of x will be equal to your sec squared x times 1 minus x squared minus 10x negative 2x over 1 minus x squared. Then you can square that. And they say do not simplify your answers, so you can leave it as this and then it will still be okay. Next one, we move on to question 7. It says f of x being equal to x to the power of 10x. So since we have our x in our power as well, to be similar to this one, so we're going to say let y be equal to x to the power of 10x, then ln of y being equal to 10x ln of x. And then now you can treat this as a product, so this one becomes y prime over y being equal to 6 squared x ln x plus 10x times 1 over x. Hence your y is equals to x over 10x, so we can just multiply by x over 10x. So y prime we go to x to the power of 10x of 6 squared x ln x plus 1 over x 10x. Okay, and then moving on to the next one, number 8, we says h of t is equals to t sine 1 over t. So you can already notice that this is this product rule. So your h prime of t will be equal to sine of 1 over t and plus t and then cos of 1 over t, and then you differentiate what's inside the bracket, so it's times negative 1 over t squared, like that. Okay, and then number 9, f of x being equal to 1 over arc sine of 2x. So with this one, you can see that it's a fraction, so we can use the quotient rule. So hence your derivative becomes so your denominator is going to be arc sine of 2x squared, and then the first part is going to be 0, so it's 0 minus, then minus 1 times the derivative of that. The derivative of that is 2 over root of 1 minus 4x squared. Hence you can as well write your answer is negative 1 over arc sine of 2x squared times your 2 over root of 1 minus 4x squared. Like that. So that will be your derivative. Okay, so number 10, f of x being equal to arctan of root of 1 minus x. So this one, you have to know what the derivative of arctan of x is, then you can work from there onwards. So your solution, we're supposed to get 1 over 1 plus your x. So your x was root of 1 minus x, and you square that, and then on your numerator is going to be the derivative of that, which is just equal to times, it's a half 1 minus x, the power of negative half, times negative 1, and then that will be your final answer. The last one on derivatives in this question is going to be f of x being equal to the square root of arcsine of t cubed. So you have to be able to know what the derivative of arcsine is, and if you do know, you get an answer. Okay, f prime of x being equal to your half arcsine of t cubed to the power of negative half, because you're differentiating that, and then times 3t squared, so it's the derivative of what's inside the bracket, over square root of 1 minus your x, which is t cubed, then squared, like that. So you have to know the basic ones, and then you can play around them, manipulating them so that they can suit what you'll be doing. So you have to know arcsine, arctan, arcsine, arctan, and then your exponents, your ln, your cos, your tan, and the normal ones, the normal polynomial ones. Okay, so another common question in this theme would be, we're going to use derivatives of sine and cos to prove another derivative. So in this case, says prove that the derivative of cot x is equal to negative cos x squared x by using the derivatives of sine x and cos x. So for this one, what you do is the derivative of cot x. So you have to know what cot x is, which is cos x over sine x. So cos x over sine x. And now that you can see that you have the derivative of a fraction, so you're going to use the quotient rule, which will give you a negative sine x sine x minus cos x over sine x squared. And over here you can factor out negative 1, left with sine squared x plus cos squared x over sine squared x. And we know that, but sine squared x plus cos squared x is equals to 1 from our trig identities, hence you're only left with negative 1 over sine squared x, and 1 over sine x is cosec, so 1 over sine squared x we go to negative cosec squared x, And then you can say it's equal to the right hand of this equation, or to right hand side. Then you would have proven. Okay, and then the second part would say if f of theta is equals to cot theta over ln theta plus sine theta, find the derivative of f theta. So from here you can already see that this is a product, there's a quotient, so you're going to use the quotient rule, and you already know what the derivative of cot theta is. Hence you can say f prime of theta will be equal to negative cosec squared x times ln theta plus sine theta, and then now it's minus cot theta times 1 plus cos theta over theta plus sine theta. And then for the denominator it's going to be ln theta plus sine theta. The whole denominator is squared. Then you have your value for the derivative of f of theta. Okay, so the last question on theme 3, derivatives of polynomials in R. Okay, so it says assume d dx, the derivative of cos x being equal to negative sine x. Use this to find the derivative of sec 3x and simplify your answer. Okay, so you have to understand what sec 3x is, and sec x is 1 over cos x. So d dx of sec 3x will be equal to d dx of 1 over cos 3x. Hence, using the quotient rule, you find out that you get negative sine 3x times 3 over cos squared 3x, which is just equal to 3 sine 3x over cos squared 3x. But we know that sine over cos will give us a tan, so we can write 3 sine 3x over cos 3x times 1 over cos 3x. Hence you get 3 tan 3x times sec 3x. So when it comes to trig functions and differentiation, you have to know the main ones so that you can manipulate them and eventually work around and get what you will be looking for.